Okay, so hello and welcome back. So it turns out that the question number 17 is not that complicated after all. I took a look at the solution, and you actually don't need matrix division to solve this problem. The question is basically A is equal to matrix 3, negative 2, and 4, negative 2, and I is equal to a 2 by 2 matrix, which is 1, 0, 0, 1, and you want to find K. You want to K such that A squared is equal to KA minus 2I. So you can write this equation as it is, and then substitute all of these values, and you will be able to find the value of K, because you can actually multiply K by the elements of A. Now, but first we need to calculate A squared, which is equal to A times A, which is basically 3, negative 2, 4, negative 2, times 3, negative 2, 4, negative 2. Okay, if I go for this row, this column, that gives me 9 plus negative 8. And for this column, 3 times negative 2 is equal to negative 6, and negative 2 times negative 2 is equal to 4. And this row, this column, gives me 12 plus negative 8. And this row, this column, gives me negative 8 plus 4. Negative 8 plus 4. And adding all of these together, I get 9 minus 8 is equal to 1. Negative 6 plus 4 is negative 2. 12 minus 8 is equal to 4. Negative 8 plus 4 is equal to negative 4. That is equal to A squared. So now here we have basically A squared is equal to K times A minus 2 times I. A squared is this matrix 1, negative 2, 4, negative 4. And that is equal to K times A, which is 3, negative 2, 4, negative 2, minus 2 times I. 2 times I would be 1, 0, 0, 1. Now if I do this calculation, what I will get is is basically 1, negative 2, 4, negative 4, and over here I get, multiplying K, I get 3 times K minus 3 times K, negative 2K, 4K, negative 2K, minus 2 times this matrix becomes 2, 0, 0, 2. And then if I subtract, I will get 1, negative 2, 4, negative 4. And here I have basically 3K minus 2, negative 2K, negative 2K, minus 0 is 0 just, so that is 4K, and that is negative 2K minus 2. And now I can find K from any of these equations. For example, over here I have 3K minus 2 is equal to 1. 3K minus 2 is equal to 1. 3K is equal to 2, basically 2 minus 2 plus 1 is equal to 3. That means that K is equal to 1. And if I take any of these, of course there is a problem here. Positive 2 plus 1 is equal to 3. So 1 is equal to 3k minus 2, so 3k is equal to 1 plus 2 is equal to 3k is equal to 1. Or if I take basically negative 2k, negative 2 is equal to negative 2k, negative 2k, then k is equal to 1 again. Now if I take, for example, over here 4k is equal to 4, if I take 4k is equal to 4, then k is equal to 1. If I take negative 4 is equal to negative 2k minus 2, then negative 2k is equal to negative 2, that means that k is equal to 1, and so on and so on. Therefore, k is equal to 1. So that is basically the value of k here. Okay, question number 18. Okay, so question number 18 is basically this question as follows. It is basically if a is equal to 0, negative tan of alpha by 2, tan of alpha by 2 is 0, you want to show that I plus a is equal to I minus a times this matrix. Cos alpha minus sine alpha cos alpha. Okay, now let me erase all of these things and we will solve the problem together. Okay, so now to solve the problem, so let me first calculate basically cos of let me first calculate the LHS, which is I plus a. So the LHS here is basically the LHS is equal to I plus a, and what that is basically, so I is basically this matrix 1 0 0 1. This is I and this is a. So if you add them together, you get 1 plus 0 is equal to 1. 0 plus this is negative tan of alpha by 2. 0 plus that would be tan of alpha by 2, and 1 plus 0 is equal to 1. So you would get this matrix here. That is I of I plus a. Now the RHS of this equation is basically, well, the RHS, and here you have I minus a. So let's calculate I minus a first, and then we will get to the RHS. So I minus a is equal to, again, I is the same thing as basically 1 0 0 1, and so I minus a is equal to 1 0 0 1, and subtract from that a, which is 0 negative tan of alpha by 2, tan of alpha by 2 0, and that gives you basically 1 minus 0 is equal to 1. 0 minus negative tan of alpha by 2 is positive tan of alpha by 2. 0 minus tan of alpha by 2 is negative tan of alpha by 2, and 1 minus 0 is equal to 1. So that is I minus a. Now, since I have basically, I want to calculate the RHS, so I write RHS is equal to basically I minus a times this matrix cos alpha, negative sine alpha, and cos alpha, and this matrix over here is I minus a, so I write it as basically 1 tan of alpha by 2, negative tan of alpha by 2, and 1. And we want to multiply that by cos of alpha, negative sine of alpha, and cos of alpha. And if you do the calculation, what you will get is basically this row times this column gives you basically 1 times cos alpha is cos alpha, plus tan alpha by 2, tan of alpha by 2 times sine alpha. Then this row times this column gives you negative sine alpha, tan of alpha by 2 cos alpha, plus tan of alpha by 2 cos alpha. Then you have this row times this column, where you have basically tan of alpha by 2, actually negative tan of alpha by 2 times cos alpha, plus basically 1 times sine alpha, which is sine alpha. And then you have negative tan of alpha by 2 times negative sine alpha, which is positive tan of alpha by 2 times sine alpha, and plus cos alpha, now what I can do is that I can write this as basically this matrix. I can write it as cos alpha plus sine alpha by 2 divided by cos alpha by 2, because this is because this is tan of alpha by 2, and times sine alpha, and then over here I can write negative sine alpha plus tan of alpha by 2 is sine alpha by 2 divided by cos alpha by 2 times cos alpha. And over here I have basically negative sine alpha by 2 by cos alpha by 2 times cos alpha plus sine alpha. And then you have basically sine alpha by 2 by cos alpha by 2 times sine alpha plus cos alpha. Now you can put these together and take LCM as, for example, take LCM here as, of course this is a matrix, not a determinant. And so I can take the LCM as cos of, so let me write this as basically cos of alpha by 2, and then cos of alpha by 2, so that is cos alpha by 2 times cos alpha, plus sine alpha by 2 times sine alpha, right? So I can write this as cos of alpha by 2, and here I have cos alpha by 2 cos alpha, plus sine alpha by 2 sine alpha. Over here I can erase this. Over here I can write basically cos of alpha by 2. Cos of alpha by 2. Here you have negative sine alpha cos alpha by 2 plus sine alpha by 2 cos alpha, right? And then over here I have basically denominator cos of alpha by 2. So you have negative sine alpha by 2 cos alpha plus basically cos of alpha by 2 sine alpha. And then over here you have, let me check over here, so cos of alpha 1, so 1 times this becomes negative sine alpha by 2 cos alpha plus over here you have cos alpha by 2 times sine alpha, and then you have cos of alpha by 2. So cos of alpha by 2 divided by this is 1, so you get sine alpha by 2 sine alpha plus cos alpha by 2 cos alpha, and now what is cos alpha by 2 cos alpha plus sine alpha by 2 sine alpha? That is cos of so you know that basically cos x minus y is equal to cos x cos y plus sine x sine y, right? So that is the same thing. Basically, I can write this as cos of alpha by 2 minus alpha. I can write it as basically, I can write this as cos of alpha by 2 and by the same logic you can write it also as the cos of basically, you see there's something interesting here. I have you know that cos x minus y is equal to cos x cos y plus sine x sine y, right? That we already know. Now what happens here is that I have cos alpha by 2 cos x cos alpha plus sine alpha by 2 sine alpha, which means that based on this formula I can write this numerator as the cos of alpha by 2 minus alpha, right? Now since in multiplication is in real numbers is commutative, by the same logic, if I for example write this as cos alpha times cos of alpha by 2, and write this as sine alpha times sine alpha by 2, which is absolutely possible, there is no problem with that, then that way I would write this as the cos of basically alpha minus alpha by 2, meaning that this expression is equal to cos of alpha by 2 minus alpha, and also equal to the cos of alpha minus alpha by 2, right? And you can see that here you will get a alpha by 2 minus alpha is the same thing as 2 alpha minus 2 alpha, which is equal to negative alpha by 2, and alpha minus alpha by 2 is equal to 2 So 2 alpha minus alpha, which is equal to alpha by 2. That means that this is equal to the cos of negative alpha by 2, and also to the cos of alpha by 2. And of course, you know that by the identities that we know from trigonometry, we know that cos of negative x is equal to cos x, which means that there is no contradiction here. So which means that basically cos of negative alpha by 2 is equal to cos of alpha by 2, and both of these are equal to this single expression up here, right? That's something interesting. So now what I'm going to do is write this as cos of alpha by 2, for example, minus alpha by 2, for example, minus alpha. And this one I'm going to write as, so here you have sine alpha by 2 cos alpha minus cos alpha by 2 sine alpha. So you have basically sine alpha by 2 cos alpha minus cos alpha by 2 sine alpha, which is the same thing as sine of alpha by 2 minus alpha, right? Because you know that sine x minus y is equal to sine x cos y plus, minus cos x sine y. So here you have sine alpha by 2 cos alpha minus cos alpha by 2 sine alpha, which gives you sine of alpha by 2 minus alpha, and that is basically this part over here. So this is basically sine of alpha by 2 minus alpha by 2 minus alpha. And of course the denominator is here cos of alpha by 2. Here the denominator is cos of alpha by 2. Right? Now the next thing that we have here is basically, again, here you have cos alpha sine alpha. Here I have sine alpha cos alpha by 2 minus cos alpha sine alpha by 2. Sine alpha cos alpha by 2 minus cos alpha sine alpha by 2, which is the same thing as sine of alpha minus alpha by 2. Right, so this is the same thing as sine of alpha minus alpha by 2. So I can write this as basically sine of alpha minus alpha by 2, and divide that by cos of alpha divided by 2. The next thing that we have here is basically sine alpha by 2 sine alpha cos alpha by 2 cos alpha. So you have cos alpha by 2 cos alpha plus sine alpha by 2 sine alpha, which is the same thing as cos of basically alpha by 2 minus alpha. Cos of alpha by 2 minus alpha. So you can write this as cos of alpha by 2 minus alpha and divide that by cos of alpha by 2. And therefore, we will have this matrix. We will have this matrix, and now I need to make a couple of changes here, meaning that alpha by 2 minus alpha, I need to calculate alpha by 2 minus alpha, and that is basically alpha minus 2 alpha, which is equal to negative alpha by 2. and cos of, so alpha by 2 minus alpha is equal to negative alpha by 2, and alpha minus alpha by 2, and alpha minus alpha by 2 is equal to 2 alpha minus alpha, which is equal to alpha by 2. So alpha minus alpha by 2 is equal to alpha by 2. And therefore, now over here we have cos of alpha by 2 minus alpha is cos of negative alpha by 2, which is equal to cos of alpha by 2. Cos of alpha by 2 divided by cos of alpha by 2. Sine of alpha by 2 minus alpha is equal to sine of, so you have sine of basically alpha by 2 minus alpha is equal to sine of negative alpha by 2, which is equal to negative sine of alpha by 2, right? And so I can write this as negative sine of alpha by 2 divided by cos of alpha by 2. Now sine of alpha minus alpha by 2, sine of alpha minus alpha by 2 is equal to sine of alpha by 2, alpha minus alpha by 2 is sine of alpha by 2. So I can write this as sine alpha by 2 divided by cos of alpha by 2. And cos of alpha by 2 minus alpha is equal to cos of negative alpha by 2, which is equal to cos of alpha by 2. And so you have cos of alpha by 2 divided by cos of alpha by 2. And therefore, I can say that this is equal to cos of alpha by 2 by cos of alpha by 2 is equal to 1. And sine alpha by 2 by cos alpha by 2 is tan alpha by 2. So that's negative tan of alpha by 2. And sine alpha by 2 by cos alpha by 2 is tan alpha by 2. And cos alpha by 2 by cos alpha by 2 is equal to 1. And that is equal to, so this was your RHS, and it's actually equal to LHS, which is equal to 1 negative tan of alpha by 2, and tan of alpha by 2, 1. So it's equal to your, it's actually equal to your LHS. So we have proved the, whatever it was that we wanted to prove. Okay, so the next question that we have is a little bit different. Okay, so the next question, that we have is question number 19, and the question is basically a trust fund. A trust fund has 30,000 rupees. So you have this is question number 19. And there is a trust fund that has 30,000 rupees. And this 30,000 rupees, this must be invested in two types of bonds. Two types of bonds. Let's call it, for example, B1 and B2. Bond 1 and bond 2, right? Now let's pretend that we know what a trust fund is and we know what a bond is. For the sake of this argument, I'm not an expert on bonds and trust fund and that sort of thing. You must be a banker to know all of that, or you need to at least do an MBA in economics and that sort of thing. But in short, the trust fund is a fund, meaning an amount of money that people will contribute to usually on a monthly basis. And then this trust fund, because it's supposed to basically create or generate more money, usually what you do with that, either you do something with the money. For example, you buy houses, you buy property, you buy, I don't know, something that over time is whose value is increased. And then after a while you have to basically you have to sell whatever you bought, and then the profit is going to be paid back to the trust fund, and therefore the trust fund will have some more amount of money after a while. And this has to be done because otherwise the trust fund would not exist. The trust fund usually exists only because the amount of money that you contribute to it increases. Otherwise, people would not be enticed into paying money into trust funds, right? Now, a bond is basically you could say that it's some sort of document that is issued by some authority, for example, by a government. And that is done because usually I, as an individual, I do not know what to do with my money. Meaning that I cannot produce anything, I cannot get into any industries, I cannot be useful on my own. And I usually don't have enough money to go and buy, for example, a whole lot of, for example, iron and keep it for a long amount of time or for some amount of time and then sell it so as to generate some money. My money is, as an individual, is limited. I cannot get into property and that sort of thing. So what I do is that I go and buy some bonds issued, for example, by a person in authority or a person that can be trusted. And then this person issues these certificates that you have paid them some amount of money. They take your money. They invest your money in some sort of financial in some sort of financial project. They will work on your money. They will invest it. They will generate some profit. Some of the profit goes to the issuer of the bond, and some of the profit is paid back to you, and that way you will get some profit on the amount of money that you have. So now this trust fund, since it wants to generate some money on the amount of money that it has, which happens to be 30,000 rupees, they have to go and buy these bonds. And there are two types of bonds, but bonds that they can choose from or that they can buy. For example, B1 and B2. So now we have a little bit more information about the situation. Now, the first bond that we have over here, that basically pays, this one pays 5% interest. That pays 5% interest per year. The second bond that we have here, that pays 7% interest. That pays 7% interest per year. Meaning that if you, for example, if you invest, for example, $100 in this bond, after a year you will have $105. If you invest $100 in this bond, after a year you will have $107. You will get that money back, of course, depending on the conditions of the bond and so on and so forth. So now what we want to do, we want to use matrix multiplication and determine how to divide this amount of money between these two bonds in such a way that at the end of the 1 year period, we will have 1800 rupees in profits, right? So we want to, basically what we want to know, we want to determine how to divide the 30,000 rupees. Actually, 30,000 rupees is not even that much money, meaning that, well, you could hope that you would get more, at most 1800 rupees or so using that money, but so we want to determine how to divide the 30,000 rupees among the two, or between the two, between basically B1 and B2 in such a way that the trust fund will obtain an annual total interest of A, 1800 rupees, and B, 2000 rupees, right? So that's what we want to do. Now, an annual total interest, basically what we are looking at here, the annual total interest is basically the amount of money. So if you're looking for the annual total interest, is basically comes from two places. You have two investments. You have an investment in the bond B1 and you have an investment in the bond B2. Let's take the investment in the bond B1 as, for example, X. Let's take this investment in the bond B2 as Y, for example, right? So that means that whatever the amount of your investment in the bond B1, that will be multiplied by 5%, and 5% of that will be paid back to you as interest. Which means that, so the annual total interest would be basically 5% of your contribution to the bond B1, and also 7% of your contribution to the bond B2. Actually, that would be Y, basically, right? That would be Y, right? So now, and this is supposed to be 1800 rupees. This is supposed to be 1800 rupees. That means that I need to somehow figure out how to take care of X and Y in such a way that basically I choose X as such an amount and Y as such an amount, such that basically 5% of X and 7% of Y, when I add them together, it becomes 1800 rupees. So I can write basically 5% of X plus 7% of Y is equal to 1800. Now here there is a problem, and that is depending on how much I invest here, I will have some money left for Y, meaning that the more that I invest here, the less money remains for me to invest on Y, and vice versa, of course. So which means that I can, but the good news is that I know that basically the amount of, the total amount of investment for me is basically 30,000 rupees. I don't have more than 30,000 rupees, so x plus y becomes 30,000 rupees. Which means that y is equal to 30,000 minus x, right? So here I can write basically 5% of x plus 7% of, instead of y, I can write 30,000 minus x is equal to 1800. And now I have only one variable here. So I can solve for that. Now what I can do, now of course I need to do this using the concept of matrix multiplication. Now basically the rates of interest of the two bonds are basically 5% and 7%. And the amount of investment that I can do are x and 30,000 minus x. Now I need to somehow, and you see that 5% has to be multiplied by x and 7% has to be multiplied by this one, and it has to be equal to 1800. And I have to do this using matrix multiplication, meaning that I can write 5% and 7% this way as a matrix, as a row matrix, and I cannot write both of them as row matrices because what happens is that this is a 1 by 2 matrix, and a 1 by 2 matrix, if I multiply it by another 1 by 2 matrix, these two numbers would not be equal, and so the matrix multiplication would not be defined. So that means that I have to use a column matrix for the second one, meaning that I write, for example, the second matrix as I write it as x and 30,000 minus x as a column matrix, and now I have a 2 by 1 matrix. Now this 2 is equal to this 2, multiplication is defined, and this gives me a 1 by 1 matrix. So I multiply these two matrices together, and this has to be equal to 1800. I just write it as a 1 by 1 matrix. 1800. And of course you can see that when I multiply these two matrices together, that actually gives me a 1 by 1 matrix. So now there is something here that of course you can pay attention to, and that is, if I write this matrix as 5% and 7% as a column matrix, as a 2 by 1 matrix, and write this matrix as x and 30,000 minus x as a row matrix, as a 1 by 2 matrix, of course multiplication would be defined. But then in the process of matrix multiplication, I would write this as, I would get a 2 by 2 matrix, which is not what I need. And what would happen is that I would have 5% of x here, 5% of this amount here, 7% of x here, and that's basically that's basically not what I'm looking for, really. Meaning that it wouldn't help me in my particular situation. So I'm not going to do that. So what that means is that now I can do the matrix multiplication. This row times this column gives me basically 5% of x plus 7% of 30,000 minus x is equal to, and that is a 1 by 1 matrix, and that is equal to 1800 as a 1 by 1 matrix, which means that basically 5% of x plus 7% of 30,000 minus x is equal to 1800, and that means that basically now you can simply solve for x. Now to solve for x, you can write this as 5% of x plus 7% of, for example, times 30,000 minus 7% of x is equal to 1800. And then to get rid of these hundreds in the denominator, multiply by 100 every term in the equation, you'll get 5x plus 7 times 30,000 minus 7x is equal to 1800 times 100 is equal to 180,000. And that is equal to 5x plus 21 4 zeros minus 7x is equal to 180,000. And then 5x minus 7x is equal to negative 2x is equal to, this taken to the other side becomes negative 210,000 plus 180,000 would be 210,000 minus, if I take it the other way around so that I can do the calculation, I get 180,000. And then if I subtract, I get 0, 0, 0, and then 111, 3, that's negative 30,000. Negative 30,000. And that gives me 0, and this that we can cancel out. X is equal to this divided by 2, which is equal to 15,000. Now, since we know that x plus y is equal to 30,000, therefore, if x is equal to 15,000, then y becomes also 15,000. And that means that if you invest 15,000 rupees in bond 1 and 15,000 rupees in bond 2, that gives you 1,800 rupees at the end of the year. That amount of money at the end of the year. And we can actually test that, meaning that 5% of 15,000 plus 7% of 15,000 is equal to what? So 5% of 15,000 plus 7% of 15,000, and then you can write this as 150. You can write this as divide by 100, you'll get 150, and this becomes a 7. Now 7 times 150 plus 7 times, actually 5 times, that's equal to 5 times 150 plus 7 times 150, which is the same thing as 5 times 15 is equal to 775, so that's 750 plus 7 times 15 is equal to 70 and 105, so 150, and that is the same thing as exactly 1,800. Right, so that is, and then you can use the same basically logic and the same way of solving the problem in order to solve for example, 2,000 rupees. So now there is the next question, which is question number 20. Okay, so now let's do question number 20. It says that the bookshop of a particular school has 10 dozen chemistry books. You have 10 dozen chemistry books, 8 dozen physics books, 8 dozen physics books, and you have 10 dozen economic books. Their selling prices are 80, 60 and 40 rupees each. So you have 80 rupees each. That is the selling price. You have 60 rupees each for these books, and 40 rupees each for these books. Find the total amount the bookstore will receive from selling all the books using matrix algebra. So you want to find the total amount the bookstore will receive as a result of selling all the books. And that of course you want to do using matrix algebra, and then assume x, y, z, w, p are matrices of order 2 by n, 3 by k, 3 by p, 2 by p, 3 n by 3, and p by k respectively. Choose the correct answer in exercise 21 and 22. Now that's actually another question, I'm sorry. Okay, so then you have 10 dozen chemistry books. Now 10 dozen means 120, I suppose, because a dozen means 12, right? So 10 dozen means 120, 8 dozen means 8 times 12, and 10 dozen is 10 times 12. So that means that you have 120 books here. You have 8 times, what is 8 times 12? 8 times 12 is equal to basically 80 plus 16, which is equal to 96. And 10 dozen is again 120. So to set up your matrices, you have the total amount of money that they will receive is basically 120 times 80, because each of those books will be sold for 80 rupees. So you have 120 times 80 times 80, and that has to be added to 96 times 60, and that has to be added to 120 times 40, and that, whatever that is the total amount of the books that the bookstore will sell. So it's obvious that we have to have a column matrix and a row matrix, because in the end we are supposed to end up with a matrix, with a 1-by-1 matrix. So it's just the same as the previous question that we had. So now if I set up the number of books as 120, for example, 96 and 120 as a column matrix, and multiply it by a row matrix of 80, for example, 60 and 40. So this is a 3-by-1 matrix. This is a 1-by-3 matrix. And that gives me a 3-by-3 matrix. I'm not looking for this. So I will write this as a row matrix. I will write this as a row matrix, meaning that I write 120, 96, and 120 as a row matrix, and multiply it by a column matrix, which is a 80, 60, 40, 80, 60, 40, and that gives me basically, this is a 1-by-3 matrix. This is a 1-by-3 matrix. This is actually that has to be a column matrix. I apologize. So this has to be a column matrix, which is 80, 60, 40, 80, 60, 40. And so here you have a 1-by-3 matrix. Here you have a 3-by-1 matrix, and multiplication is defined, and you will get a basically 1-by-1 matrix, which means that you will have 120 times, for example, 80 plus 96 times 60 plus 120 times 40 as a matrix of 1-by-1, and then if you do this calculation, you will get basically what is 8 times 12? That's 80 and 1696 and 2 zeros. What is 6 times 96? That's 540 and 36. So that's 6, 7, 5, 76 and a 0. 5, 76 and a 0. And 4 times 2 is equal to 48 and 2 zeros. And then you have 9, 6, 0, 0, 5, 7, 6, 0, and 4, 8, 0, 0, which will give you a 0, 6. 14 plus 7 is equal to 14 plus 7 is equal to 21. Is equal to 21. 11 plus 9 is equal to 11 plus 9 is equal to 20. That's 20,100. That's 20,160, and that is the total amount of money that the bookstore will receive, right? $20,160, right? Okay, so that was question number 20. We have question number 21 and 22. Those two we will do in the next video. I'll see you in the next video, and thank you.